Given h of x equals 2x plus 1 over x minus 3, and being told that it's a one-to-one function so we don't have to verify it, find the inverse function h inverse of x, find the domains of both f and f inverse and the range of both f and f inverse. Okay, so they already told us it's a function, a one-to-one function, so we do not need to verify it. We'll just do step 1, replace the h of x with y, so we have y equals 2x plus 1 over x minus 3. Step 2, we want to solve for x, so let's get rid of the fractions by multiplying both sides by the LCD. We'll get this, and then getting rid of the parentheses, and gather all the x terms on the left side. So anything containing x moves to the left, everything else moves to the right. Now on the left side, we can factor. Well, let's move it over first. xy minus 2x equals 3y plus 1. Now we have all the x's on the left, so let's factor out the x from that side. We are left with x, parenthesis, y minus 2 equals the other side. And now solve for x by dividing both sides by y minus 2. And we've got x equals 3y plus 1 over y minus 2. Step 3, switch the x's and y's name, rename them y equals 3x plus 1 over x minus 2. And now, step 4, replace y with h inverse of x. It equals 3x plus 1 over x minus 2. Now for the domain of h, just look up on top at the h function they gave us. There was one restriction, and that was we could not let x equal 3 or it would give us a zero denominator. So the domain of h is a curly step bracket, all real values x such that x is not equal to 3. Okay? Now that happens to be the domain of h. It's also the range of h inverse in terms of y instead of x values. All real numbers y such that y is not equal to 3 is the range of h inverse. The domain of h inverse, we'll look at h inverse. The domain is a restriction that x cannot be equal to 2, but that's also the range of the opposite function h in terms of y. Y cannot be equal to 2. So I could have stated it a little clearer, but you understand the concept. If you know one in terms of x, you know the other in terms of y.